Welcome back, everyone. I'm Dr. Jared Boasen, continuing our EEG training with EEG installation. And the next step in our video is now going to be powering on the amp and connecting it to our EEG recording software. So the first step here is we need to make sure we can connect the software to the amplifier. We're using a brain vision system, and Xavier is going to now search for the amplifier using the software and make sure we can find it. So it automatically comes up. That's good news for us. It means we have good battery power and the signal is there. So it's going to connect the amplifier. We got a green indicator light that says we're good, we're connected. Thank you, Xavier. And then the next step that I'd like to do before we do anything else is to make sure that we're using an appropriate workspace for our EEG recording. So I'm going to ask Xavier to open up our workspace and go into the editing screen. Now he's already preloaded a workspace for us here, but as a general rule, anyone doing EEG recording should always verify their workspace prior to starting an experiment. It's very important. Go ahead and go to the next screen. Thank you. So in the Brain Vision Recorder software, the first window that comes up as we verify the workspace is the list of all the electrodes that are connected to the recording software. And we can see that list there. There are supposed to be 32 channels on this bundle. We can see that there are indeed 32 channels. Perfect. The other important thing that we need to verify is this name column that Xavier has the mouse cursor over right now. That name column will have the anatomical name of all of the electrodes. Now this anatomical name is dependent upon the electrode montage that you're using for your experiment. So you need to make sure that it actually matches the montage that you chose when you put the electrodes into the cap. Now I can see right away that this is correct, and not having the names in this position will cause a lot of headaches later. It'll leave a lot of questions on what exactly was the anatomical position, first of all, and second of all, it'll make it difficult for you to do any intelligible analysis on your data because you won't actually know what the anatomical positions are in any of your visualizations. So that looks good. And the sampling rate we also want to check. Whoever the scientist is on your study, they're going to tell you what sampling rate they want to use for the experiment. As a general rule, we tend to use 500 Hertz as our sampling rate here in the lab. It's more than what's necessary for EEG, but it does allow a lot of flexibility in your analysis later on. We can go as high as 1000 Hertz, but for the most part, that's not necessary. But again, talk to the lead scientist on your study to find out what the appropriate sampling rate should be for your case. Thanks, Xavier. Let's go to the next screen. All right. The next thing we need to check is when we're recording, are there any filters being applied? For this case of this EEG training, I want to record raw EEG data. And that means I want to make sure that on this tab on the filter screen where it says raw data, we have 0 filters applied. And you can see the checkbox for enable filters is not selected, so no filters are going to be applied to the raw data. However, when we conduct a study, we want to be able to clearly see what's happening. And that means we want to remove some of the noise to make it easier for us to know if the electrodes are behaving properly. So we will want to apply some display filters. So please go to the display filter tab. Thank you, Xavier. So as a general rule in North America, we have alternating current coming out of our power sources. And that current is flowing at a rate of 60 Hertz. So usually we want to have a notch filter at the rate of alternating current. We call this line noise. And you can see we have a notch filter applied at 60 Hertz. We also don't really need to see what's going on above a threshold of around 40 Hertz. Why? Because most of the neurophysiologically relevant signals are below that frequency. So things like delta and theta and alpha and beta, you may have heard of these. These are all below 40 Hertz. So we'll go ahead and apply a high cutoff filter at 40 and it'll make it much easier for us to see what's going on with our data. Thanks, Xavier. Let's go to the next screen. Great. This last one is not really necessary for students at this lab to worry about. So as long as nothing is selected here, you're good to go. And if you haven't made any changes on the workspace, then you can just close this and there's no need to save anything. If you have made changes, obviously you should save this as a new workspace and make sure that you're using that correct one for your study. Great. Your next step, I want to actually see the signals. So Xavier is going to press the little eye icon there, and we're going to see what the signals look like completely raw. I want to make sure that we don't have any dead channels. If we had a dead channel, we want to know about that beforehand, so we can make a note. And potentially at this stage, we could even change out the electrode bundle if there were multiple problems. At this lab, we do have multiple bundles available. So if you decide that the costs of losing certain electrodes are too high, we can always replace out the bundle and we can have the broken one repaired. And you can see that there are some very high amplitude squiggly marks on here. That's normal. We don't have any conductive gel applied yet. However, for dead channels, what we're looking for is a completely flat channel. And we don't see any of those. So that's good news for us. The next step we're going to move into in the next scene of this tutorial series is the impedance check. And that's where we'll apply the electrode gel. So I'll see you soon.